Imagine you park your car outside a store. It's a mild day, not even that hot. 75 degrees maybe. You run in for one thing. You'll be back in 5 minutes. Here's the question almost nobody can answer correctly. How hot does the inside of that car actually get in those 5 minutes? Most people assume a mild day means a safe car. Cool outside, cool enough inside, right? But under the surface, it's not weather that decides this. It's physics. And physics doesn't care how the day feels to you. By the end of this, you'll understand why a mild 75-degree day can turn a car into something more dangerous than the surface of a desert, and why the human body has almost no defense against it. Let's break down the simple physics first. A car is essentially a greenhouse on wheels. Sunlight passes through the glass easily. But the heat that sunlight creates when it hits the seats, the dashboard, the steering wheel, that heat is a different wavelength. And that different wavelength struggles to escape back through the glass. Energy comes in easily. It leaves slowly. That imbalance is the entire problem. Here's the number that should genuinely alarm you. On a 75-degree day, the inside of a parked car can climb by 20 degrees in just 10 minutes. Within 30 minutes, it can pass 100 degrees. Within an hour, it can exceed 120. Think about the cost-benefit math your brain is running when you say, "I'll just be 5 minutes." 5 minutes feels harmless. But the car doesn't measure harm in minutes. It measures it in degrees per minute. And in the first few minutes, the temperature rises fastest of all. Cracking a window barely changes any of this. Studies have shown it lowers the temperature rise by only a few degrees. The math simply does not work in your favor. Not on a mild day, not on a cool day, not ever. Now here's where this stops being about numbers on a thermometer and starts being about what those numbers do inside a body. Your body is built to cool itself in one primary way: sweating. As sweat evaporates off your skin, it pulls heat away with it. It's an extraordinarily efficient system. But it depends on one condition. The air around you has to be cooler than your skin, and it has to be moving. Inside a parked car, that condition disappears almost immediately. The air stops moving. The air temperature rises above skin temperature. And once that happens, sweating doesn't cool you anymore. It just adds humidity to an already suffocating box. This is the mechanism researchers call hyperthermia, and it's especially catastrophic in children. A child's body heats up 3 to 5 times faster than an adult's. Their internal cooling system is smaller, less developed, and working against a much larger surface area to body mass ratio. Dr. Catherine McLaren, a leading researcher on vehicular heat stroke at San Francisco State University, spent years documenting exactly how this unfolds physiologically. Her research helped establish the now widely cited data. A child's core body temperature can reach a fatal level of 107 degrees Fahrenheit in as little as 15 to 30 minutes inside a hot vehicle. Once core temperature crosses that threshold, proteins inside the body's cells begin to physically break down. This isn't discomfort. This isn't dizziness. This is organ failure. The heart, the brain, the kidneys, shutting down almost simultaneously because the proteins that keep them functioning have literally lost their shape. And here's the part that makes this especially insidious. Investigations into these tragedies, tracked for years by organizations like noheatstroke.org, reveal a pattern. It's rarely negligence in the way people assume. In the majority of documented cases, a change in routine, a different driving route, a sleep-deprived parent, a switch in who normally does daycare drop-off, causes the brain's autopilot memory system to override conscious awareness entirely. The parent doesn't forget because they don't care. They forget because human memory has a well-documented failure point, and a hot car exploits it perfectly. Here's the strange part. Your body already knew heat was dangerous, long before anyone measured it in Fahrenheit. For nearly the entire span of human evolution, we lived in open air. Wind, shade, water, always accessible, always part of the escape plan. Every heat regulation instinct your body has was built for a world where you could always move somewhere cooler. A sealed glass box breaks that ancient assumption completely. There is no wind, there is no shade, there is no moving to somewhere cooler. Evolution never prepared your body for a fully enclosed, transparent oven, because nothing like it existed until roughly a century ago. This is also why the memory failure isn't a character flaw. It's a design flaw baked into how brains evolved to run on autopilot. Habitual routes, repeated routines, well-worn driving patterns, these all exist because your brain evolved to conserve energy by running familiar tasks unconsciously. It's a brilliant survival tool for almost everything else in life. In this one specific modern scenario, it becomes catastrophic. Now, the exceptions, the cases that seem to break the pattern but actually prove it. Some animals, like desert-dwelling reptiles, can tolerate extreme heat because their bodies evolved with drastically slower metabolisms and specialized heat-tolerant proteins. Humans never evolved that tolerance because our ancestors never needed it. We evolved as mobile, shade-seeking creatures, not heat-enduring ones. The reptile's tolerance doesn't contradict the danger to humans. It confirms that heat tolerance is a specific evolutionary adaptation humans simply never developed. And modern safety technology, heat-sensing car seat alarms, rear seat reminder systems, works precisely because it does what evolution couldn't. It inserts a conscious alert into a brain process that runs on autopilot. The technology isn't fighting human nature. It's compensating for a blind spot evolution never had a reason to fix. So let's step back and look at the whole picture. A parked car isn't dangerous because of some rare, extreme heat wave. It's dangerous because of ordinary physics, working exactly as physics always does. Sunlight in, heat trapped, temperature climbing fastest in the very first few minutes you'd least expect it. And it's dangerous because the human body, brilliantly engineered for almost every environment our ancestors ever faced, was never built for a sealed glass box under direct sun. Not children, not adults. The physics doesn't discriminate. It simply overwhelms the smaller, faster system first. Maybe the real lesson isn't about heat at all. It's about how easily an efficient brain, the very same efficiency that lets you drive to work without consciously thinking through every turn, can become the most dangerous blind spot you'll ever carry. 20 minutes doesn't sound like much time, but inside that glass box, 20 minutes is exactly how long it takes for ordinary physics to become irreversible.